thermal fluid sciences experts. This is ProReadyEngineer.
Temperature. When you work with thermal fluid sciences, when you work in different fields, almost all fields maybe, it's a good guess to make. Temperature is very important for us. I want to talk to you today about temperature, about pressure, about density, about viscosity, and on and on and on. All these. When I want to talk to you about them to set you up for success, I want you to understand not only what they mean, which is what you would find in your textbook, is what they mean. I go beyond that. I want you to know what they mean, how much is a lot, how much is too low, how much is an intermediate. I want you to know how do we measure it. And if you know those three things, what does it mean? What's the order of magnitude? How do we measure it? You are on your way to succeed, right? Temperature is a measure of the kinetic energy of the particles in a system. It's a very dry definition. I don't like it, okay? But a much better is that second line item here. It's the degree of coldness and hotness. That resonates right away when you say degree of how something is very hot or cold, because that's how we feel, right? So this second line item is really what makes sense, is what I want you to remember. Now let's build a feel for it. You see, temperature, I started with it because everyone listening to this will immediately relate if I tell you it's freezing. You know what does freezing mean? You know what it implies. You know how it feels. You know what happens. If I tell you this is boiling water, you know it's too hot. You know it will burn your skin. You know you have something to compare to. You know that water boils at 100 degrees centigrade, 212 F Fahrenheit. So if I tell you that temperature is 3000 F, you say, boy, man, this is scary, this is tremendous. In fact, even if I just tell you the temperature is 1000 F, you say this is humongous. 1000 F is humongous because 212 will boil the water. You're talking here a lot of temperature. See, that's the feel we are talking about, right? So to give you a little bit more feel, grilling, when you go outside grilling, that temperature is somewhere around the 400 to 500 degrees. You can relate to that because your hand, when it goes about on the top of the grill and you spend a couple seconds close, it really is, hurts, and you can't even keep your hands, and you have to move it quickly, and you can get it closed down. You have to keep it up so the temperature is lower. You can relate when I tell you that the temperature is somewhere around, the 400 Fahrenheit, give or take. You see, steel, that metal steel, it melts. It just gets oxidized at about 2800 F. It disappears, right? So now that temperature 2800 F means something big for you. So for example, just to give you one example, you say, well, if steel melts at 2800 F, different kind of steels melt at 2800 F. If I make a device that a flame lives in, right, combustion systems, which is my deep expertise, if a flame lives in and that flame is 3200 F, you say, hold on, 2800 the metal melts and this 3200 is sitting in something. You have to be doing something to cool that down. You have to. You cannot say, here's the combustor. The combustor is like the place where the flame lives. Some other presentations, if you look at my combustion arrow presentation, you know what's a combustor. That is that entity that surrounds the flame. So if I tell you there's a 3200 F flame in there, you will say that metal temperature is probably something like 1600, 1700, 1800 F, and that's about it. It's never going to be 2800. It's never going to be 2600 because this temperature, the structure will already melt. It doesn't exist. So somewhere, somehow, someone did a trick, and you will learn those tricks. I actually introduced that in my combustion aero engineer presentation. If you haven't seen it, please go ahead and take a look at it. But there are tricks that make that structure cold enough to sustain that flame sitting inside. And here is again the sun temperature. It's about 5000. degree Kelvin or 5,000 degrees centigrade doesn't matter much. You know, it's a joke. A friend of mine, I was telling him what's the sun temperature. He said, I don't know. I told him that's 5,000. So he said centigrade or Kelvin, and we had a laugh at it. Now the reason we had a laugh is, you know, the difference between centigrade and Kelvin is you add 273. So why does it even matter? What's the difference between 5,000 to 5,200? Right? Now engineers are smart. They use order of magnitude, representative numbers. You will not be a good engineer if you are the type of engineer that says the temperature is 325.265781. No, no. You cannot do order of magnitude. You do not understand when are decimal points needed and when they are not needed. Don't do that, please, as an engineer. Now, so temperature is important. I just convinced you it is important. So how do we measure it? Well, thermocouples is the number one. Thermocouples, RTDs. What is a thermocouple? Like literally, it's a wire. If you've seen a thermocouple, it's like a wire. Now, and there's a version of it that's not a wire, that is as big as that thing on the screen, like a pen, like so thick, beefed up and thick. So when do we use the big one? When do we use the small one? Well, it depends on the application, but it doesn't change the fact that this is a thermocouple. And the RTD is similar to it. It sort of looks like that, but it sits sometimes in a well. It has a different shape, but it's similar. And there is the optical pyrometer, something like this. You've probably seen it, like, you know, they sell them in terms of camera. Sometimes they do it even in your cell phone, I believe, right now. And you hold this handheld devices, you point at the thing you want to look at, and it plots, you know, to you like an image, a thermal image with the temperatures on it. These parameters sometimes are very nice, useful, and good to do checks on equipment when you are walking in the middle of equipment and you want to make sure of the surfaces around you. You hold that thing in hand and you keep pointing at structures around you, and it essentially gives you a read of the temperature. Some of them are guns that you hold in hand. And essentially these guns that you hold in hand, you aim it at the surface, and essentially you click a button, there's a laser comes out and it goes to the surface and it gives you a read on it. So now you know the magnitude of temperatures, how it's measured, what does it mean, and if we continue this way, when we talk about pressure, density, and on and on and on, then by the end of this presentation, you will be feeling very well that you understand why those things are important and how do we measure and handle them.